Starting Unit 4, Numbers of Solutions in Graphing. This is Lesson 4.1. If you haven't already, go ahead and do the warm-up problems. You guys have already finished this, so I'm going to start going over them. This is a review from Unit 2B, Graphing Linear Equations. So when we graph linear equations, the first thing we want to find is the y-intercept. Where you look at our equations, they're both given in which form? Slope-intercept form. What is the equation for slope-intercept form?
Y equals x plus b.
Y equals mx plus b. Where m is the slope and b is the y-intercept. So we're going to identify those pieces here as we graph our lines because those are the two pieces of information that we need. So starting with m, looking at this first equation, y equals 2x plus 4, the slope would be 2, the number in front of x, the coefficient of x. And if it's not a fraction to graph, you go ahead and make it one by putting it over 1. So my slope here is 2 over 1. We're going to need that because remember when you're graphing, you have to have a rise and a run. So that's why we make it a fraction only when graphing. The b is the value at the end, and you always take the sign with it. So this is a positive 4. All right, so this tells us where we're going to start our graph. We're going to start 0, 0, right? Follow up the y-axis. We're going to go up to positive 4 and draw our first point because this is the first point that it crosses on the y-axis. All right, and then we're going to use our slope, rise 2, run 1. So we're going to go rise 2, run 1. Well, there's not a point right here. It goes off the graph. So we're going to reverse that and go down to left 1, down to left 1, down to left 1. And we're going to do this all the way across, down to left 1, the entire graph. And then we can kind of check it. We're going to connect our dots. It's a little bit difficult for me to do it on this writing. It's a little bit easier for you on your paper to make it straight. But we can kind of check it here. Is our slope positive? Is it going uphill? Yes, it is. So if you got a negative slope going down this way, that means you didn't reverse the correct direction, okay? So you always want to check and make sure positive slope is going uphill. All right, so let's take a look at number 2. We first want to identify m and b, so our slope is the number in front of x. In this case, it's negative 2/3. When we graph that, we want to put that negative sign with the top number, so negative 2 over 3. And then b, there's nothing out here, so what number do we know is out here, guys?
0.
Plus 0, so that's going to be our b, is 0. So that means our first point is going to go right here at 0, 0 on the y-axis. All right, we're going to go negative 2, which tells me to go which direction? Down 2, and then right 3. 1, 2, 3. Down 2, right 1, 2, 3. So it's off the graph. Let's reverse it. Up 2, left 3. 1, 2, 3. Okay. Up 2, left 3. And I could only get 3 points on this one. And then we're going to check it. Oops. Hopefully yours is a little bit better going through the points than mine. We have a negative slope, so which way should our line be going? Downhill. Let's go over number 3 and 4. Y equals negative x. Okay, so in this case, we're still doing the same thing. We want to find m. What number is the coefficient of x? What's in front of this x here? A negative 1. That's a negative 1. And we want to make it a fraction. You put it over 1. B, what number is out here? There's nothing out here, so what number do we know is here?
0.
Plus 0. So this one's going to start at 0, and then we're going to go down 1, right 1. Down 1, right 1. Down 1, right 1. All the way across. And then we're going to reverse it. Up 1, left 1. Up 1, left 1. Up 1, left 1. And connect. We have a negative slope, and it is going downhill. Number 4. Now in this case, the first thing I notice is that in my equation, y equals mx plus b, if I'm looking for the m and the b, well, I need to find m is in front of x. Well, where's the x at in this one? There isn't one. So this is one of those special cases, if you remember. There's no x, so that means that it doesn't cross the x-axis. So which one's the x-axis? That would be this one. And remember, this is your y-axis. So it doesn't cross this line at all, okay? It's only going to cross the y-axis at what number? At 3. So let's go up on the y-axis and put a point at 3, at positive 3 on the y-axis. All right, so it's going to cross right here on the y-axis, but it's never going to cross the x-axis. There's no x in the equation. So what type of line is it going to be? A horizontal line. It runs parallel with the x-axis, which is why it never crosses the x-axis. It runs parallel with it. It's never going to intersect this line down here because they're just going to run parallel forever and ever. So if you see y equals a number, remember that is always a horizontal line. Okay? All right, the next one, number 5, is x equals negative 2. So for this one, what are we missing this time? We're missing the y. So that means that this time there's no y in the equation. It's never going to cross the y-axis. But we know that it crosses the x-axis at what number? Negative 2. So on your x-axis, come down here and draw a point at negative 2. I need everyone to check and do this with me. All right, so negative 2, we're going to cross right here, but we're never going to cross this y one. So what type of line is x equals going to give us? A vertical line. So that means it's going to be vertical. And you might want to make a note on your warm-up paper so that you remember if you're given x equals a number and there's no y in the equation, it's going to be a vertical line at whatever this number is. On the previous problem, number 4, if you're given y equals a number and there's no x, it's a horizontal line at whatever the y equals. Okay? All right, number 6, last one. I want everyone to kind of look at it and see if you need to make any changes before we go over it. If you haven't given number 6 a try, go ahead and do that before we go over it. I'm going to give you 30 seconds. Give it a try. All right, where are we going to start with our m? What is our slope in this case? 1/4. The coefficient of x is 1/4. It's already a fraction, so we leave it. And what is the b value? -1. Make sure you remember to take that sign in front. So this means our graph is going to start at -1 on the y-axis. That's our y-intercept. So we're going to go to -1 and draw our point. And then we're going to rise and run using our slope to find all of our other points. So we're going to rise 1, run 4. All right, that's as far as we can go. It goes off the graph. So we're going to go down 1 and left 4. I can only get 3 points on this one. Whew, oof, that was a bad line. Let me try that again. There. That's a little better. Hopefully yours looks better than mine. All right, so now we've warmed up remembering how to graph lines, and we need that because our first lesson here, 4.1, for systems of equations is what we're going to be starting this unit. Unit 4 is titled Systems of Equations. Lesson 4.1 is solving systems of equations graphically. So it starts out really easy with stuff that we already know from last unit, graphing lines. We want to look at how to solve a system. So first I want to talk about what a system is. Go ahead and turn to your notes now, the notes page. So we're at the top. Make sure your name's on your paper. A system is more than one linear equation. That's all we call a system. You could have 2, 3, 4. Typically, it's just 2, but as you get into more and more advanced maths, you'll be graphing more and more lines on the same graph. Okay, so that's what we're looking at doing now. So it starts with saying, graph the following equations. So we have y equals negative x plus 7. We want to identify our slope and our y-intercept, and then we have y equals 2/3 x plus 2. So starting with the first one, what is our slope? All right, so we have the negative sign here in front, which we know that means -1, and we want to make it a fraction, so we put it over 1. I write, you write. We're going to find our y-intercept. That is always after the variable x. In this case, we have a positive 7, and that tells us where we're going to start our graph. So I'm going to start at positive 7. Follow your y-axis up to positive 7 and draw your first point. We're going to use our slope to find all of our other points. So down 1, right 1, because the -1 tells you to go down first. Down 1, right 1. Down 1, right 1. Do this the entire way across your graph. And then reverse it. Up 1, left 1. And then carefully connect, drawing your line. Notice all of these are very linear. It's not like a scatter plot. They are in an exact straight line. There should be no curves in these. All right, I'm going to switch colors because now with the system, we're going to be graphing more than one line on a piece of paper. Okay, you can do both in your pencil. That's fine if you want to label them so you know which one's which. Or if you wanted to do colors, you could. It's up to you. So starting with our slope, m is going to be our 2/3. So I'm just writing rise over run 2/3. And then our b this time is positive 2. So I'm going to start my graph at positive 2. And I'm going to rise 2. Run 3. And there's already a point there, so I'm just writing over it. And then I'm going to rise 2, run 3. Rise 2, run 3. And then reverse. Down 2, left 3. Down 2, left 1, 2. And connect that as straight as you can. Hopefully yours is very straight compared to mine on this tablet. And we just graphed our first system. Okay, now what do you notice is happening with these two lines? What are they doing here? They're crossing, they're what? Intersecting. Okay, they are intersecting. So on the next part, it says all of the points on the line are solutions to that equation. Go ahead and fill in that blank. So every point on this first line that we made will solve this equation here. Every one of these points that we plotted. All of the points on this line will solve the bottom equation. However, the one point that will solve both of them is where they intersect or where they cross. This point right here will solve both equations. You can plug it into this one and it works, and you can plug it into this one and it works. So when we have two lines that intersect, there's one solution that works for both of them, and that's what we're trying to find. The point that will satisfy both equations and make both true. So let's look at the next part. It says number 3. What type of lines are these? We call these intersecting lines. Intersecting lines. Whoop. That's one I-N-G, lines, intersecting lines. And what is the solution? So we're going to write this ordered pair right here. What is this point right here where they both cross? So start at 0, 0. We're going to go right all the way between 2 and 4. What number would that be? 3. And we're going to go up to the y value of 4. So our ordered pair that's the solution is 3, 4. This is the solution. This is what type of lines they are intersecting. And that's how you solve a system of this type. Let's look at another type. Example 2. Start by graphing your lines. Identify your M and B. The slope is 1/2. The y-intercept is 7. Okay? It's already a fraction, so leave it. Go ahead and try graphing this. We're going to start at positive 7, and we're going to go which direction? Rise, then run. Rise, run. Rise, run. Rise 1, run 2. Rise 1, run 2. Reverse it, down 1, left 2. Connect your lines. Oof. Try that again. I'm going to switch colors. Y equals 1/2 x plus 4. This time my slope is 1/2. And my B is a positive 4. We're going to start our graph on the y-axis at positive 4, so make sure you follow up your y. Plot your first point. We're going to rise 1 and run 2. Rise 1 and run 2. Rise 1 and run 2. Reverse it, down 1 and left 2. All right, and what do we notice about these two lines this time? They don't intersect. So they're not intersecting lines, right? What could we call these? Ooh, yeah, there you go. All right, so what do you notice? All the points on each line are solutions to that equation. However, there are no points where the two lines intersect. Fill in those blanks on your notes, number 2. So all of these points will solve our first equation, 1/2 x plus 7. And all of these points solve my second equation, 1/2 x plus 4. But since they don't intersect, that means that what? Is there a solution that solves both of them? No. So we call these parallel lines. And there is no solution for both of them that works for both of them. We call this no solution parallel lines because they never intersect, so there's not a point that will solve both of them. This is the type of lines. This is the solution. All right, one more type of lines we're going to look at. Graph y equals -3/2 x plus 8. So we're going to start with our slope, which is -3/2. Where should I put this negative sign, guys? With which number? Always put it on the top because that tells you to go up or down, okay? Remember to always, if there's a negative sign, you put it with the top because that tells you to go up or down. All right, and then the +8 is our B. So that's where we're going to start. Oop. So I'm going to start up here at +8, and I'm going to go down 3, right 2. Down 3, right 2. And then you can go up 3. Nope, I can't go up 3. All right, so that's as far as I can go on this one. Slowly connect. And make sure you're giving it arrows because the arrows indicate that it's going to do what?
Continue forever.
Go on and on forever. in both directions. I could give you a bigger graph, a 20 by 20, and your line would be a lot longer, right? Or I could give you a smaller graph and just give you like a 5 by 5, and it would be really small. So you got to be able to graph on all different types, depending on how big the system is. All right, so now let's do this one. So our slope is negative 6 over 4, and our y-intercept is positive 8. So we're going to start at 8, same place we started last time. And this time we're going to go down 6. 1, 2, 3, 4, 5, 6. And we're going to go right 4. 1, 2, 3, 4. There's already a point there too. Down 6 and right 4. There's already a point there. Down 6 and right, I'm out of room. So now I'm going to go up 6, up, out of room. So there's only 3 points. And what do we notice about all 3 of these points that we just drew? They're all matching. So it's through the line that we've already drawn. They're basically the same line, aren't they? Do you notice anything here about their y-intercepts? So their y-intercepts, the 8s, they're the same. They started in the same place. What do you notice about their slopes? They're both negative.
3 over 2 times 2 is...
They're the same. If we reduce negative 6/4, what do we reduce it to? Negative 3 over 2. So they have the same slope and the same starting point. That means that they're basically the same line, just written differently. Okay, so filling in the blanks on number 2. What do you notice about these lines? All the points on each line are solutions to both equations. The 2 equations can be simplified to be the same, which we just did. We simplified negative 6/4 to negative 3/2. They are the same line. Number 3, what type of lines are these? We call these coinciding. Coinciding lines. Means that they coincide, they go together in exactly the same spots. Coinciding lines. It looks like coinciding, but it's coinciding. What is the solution? All right, is this point a solution up here for both of them? Yes. Is this point a solution for both of them? No? It's not on both lines? Is it going through the black line and the red line? Yeah, it is. What about this point? Yeah, it's going through both of them. So every single point is a solution to both of them. All of them are. So what do you think we're going to put for the solution? Infinitely many solutions, because we can't really list all of them, because these lines are going to keep going on forever and ever in both directions. There's infinitely many solutions going this way and this way, so we just say this one has infinitely many solutions. You could pick any of these points and plug it in for x and y, and it'll solve both of these. Do you remember doing this with equations earlier this year? Yeah, we had equations where we had one solution, infinite solutions, and no solution. So that's basically what we're doing now. All right, so practice examples. I think that you have 5 of them. Do you want me to do 1 or 2 with you, or you just want to go through and do them yourself? Go through them and do them? Okay. You want me to do them, or do you want to try them on your own? Okay, so let you try these 5, and then I'll quickly go through maybe just a couple of them to see how you're doing. Okay? Go ahead, and if you are watching the video, you're just going to pause it and do these 5 problems. All right, I'm going to go over these quickly, starting with number 1. Graphing y equals negative 3x plus 4. So my first point is at positive 4. My slope is negative 3. We're going to make that a fraction by putting it over 1. So that means down 3 and right 1. Down 3, right 1. Down 3, right 1. Up 3. Left 1. up 3, left 1. All right, and then I'm going to do the next one. Just connect that. Whew. Wasn't very straight up here at the top. Starts at -1. Starting down here, and my slope is 2 over 1. So I'm going to rise 2, run 1. There's my intersection. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Reverse, down 2, left 1. Make sure you've attempted these. This is kind of, oops, that goes here. This is kind of the practice to make sure that you understand this concept. It's the independent practice that we kind of go over as a class to make sure you got it. All right, so what type of lines are these? They would be intersecting. And what is the solution? Where do they intersect at? What point is this, guys? 1, 1. Any questions? Number 2. First equation starts at +4. Slope is -1 over 1. So that means we're going to go down 1, right 1. Down 1, right 1. Down 1, right 1. All the way across our graph. Down 1, right 1. And then we're going to reverse that. Up 1, left 1. And if you have a ruler to make your line straight, it helps. A straight edge of any type. You can use the edge of your binder, or an actual ruler works. All right, and then my next line starts at +1. So this time I'm starting up here. And I'm going to do the same slope, -1 over 1. So down 1, right 1. So since they have the same slope, I already know that they're going to be going the same direction, which tells me what type of lines are these going to be? Parallel, because they have the exact same slope. What makes them not in the same location, though? The y-intercept. The purple line started on the y-axis at +4. The red line started at +1. So they're parallel. Are they ever going to intersect? No. They are parallel lines. And the solution would be no solution. Number 3 starts at +4. Rise 6. Run 2. Down 6. Left 2. Down 6. Left 2. Ooh. One more? Nope. Right here. That's a steep line. Whew. Not the prettiest. Hopefully yours is nice and straight. Here we're going to start at +4, same spot, and we're going to rise 3, run 1. Ooh, I need to switch colors. Rise 3, run 1. Rise 3, run 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. So these are what type of lines? Coinciding, meaning they are the same. And how many solutions? Infinitely many solutions. I'm just abbreviating because I'm trying to go really fast. Example 4. If you haven't attempted this one, do it with me. This equation, y equals 7, what is it missing? It's missing the x. That means it only crosses the y at 7, right here. So what type of line is it going to be? A horizontal. It never crosses the x-axis because it's parallel to it. It's only going to cross there. All right, my second line, y equals -2x plus 3. We're going to start at +3. And we're going to do our slope. Make sure you make it a fraction. Make sure you're keeping up. If you haven't done this one, please. Down 2, right 1. Down 2, right 1. up 2, left 1, up 2, left 1. And what type of lines do we have this time? They are intersecting, meaning that they cross. Notice, if we can already tell they're going to be intersecting because they have different slopes and they have different y-intercepts. What's the slope of the top line? What kind of slope does this horizontal line have? 0 slope. It's perfectly flat, 0 slope. So they intersect here. Where do they intersect? What is the solution going to be? They intersect at this point, which is what? -2, +7. So -2, +7 is the solution. All right, last one on the examples. We can kind of start to see, what do we notice here about the slopes? We have -6/3 and -2. What do we notice? And what do we notice about the y-intercepts? They're the same. So we're going to start at -1. And we're going to do down 2, right 1, or down 6, right 3. They're going to be the same, right? Up 2, left 1. Make sure you have these graphed on your paper, please. Catch up. All right, identify the top of lines. We said they're going to be coinciding. They are the same. Same slope, same starting place, same y-intercept. What's the solution? Infinitely many solutions. And I'm just abbreviating for you. All right, now the next one, number 6, last one. -1/4 x plus 2, so we're going to start at +2. And we're going to go which direction for -1/4? Down 1, right 4. Down 1, right 4. I'm going to go up 1, left 4. Up 1, left 4. It's a very steep line as well. Oh, I went up 2. Try that again. Stop. Oh, not a very good line. All right, and then the bottom one starts at +5, and it goes down 2, right 8. Oh, I did start at 3. Sorry. I need to start at 5. Gosh, sorry. Ignore this point. I need to start up here. Down 2, right 8. 1, 2. Is this right? Way out here? All right, and this is going to be up 2, left 8. All right, so what type of lines do we have? Parallel. And how many solutions? No solutions because they never intersect. Same slopes, different starting points, different y-intercepts. So we can kind of start to identify this before we even graph them, right? All right, let's look at the last thing is they're going to give us the lines and we need to write the equations. So we need to identify the 2 main parts and then we can write our equation, right? So let's start with line 1, which is the green line. Where does it cross at? What number is this on the y-axis? At +5. So B is +5. Now we're going to write the slope. The slope from this point to the next point. It goes down 1, 2, 3, 4. So what number would that be? negative 4, and right 1. So the slope is negative 4 over 1. And we want to simplify that to write it in an equation. What's negative 4 over 1 simplified? Just negative 4. So now we can write our equation. Y equals negative 4x plus 5. Because remember, we're doing this in the form of y equals mx plus b for now. We're only doing slope-intercept form for now. All right, I'm going to do the blue line here. Where does it cross the y-axis? We want to find m, and we want to find b. So find b first. Always do b first. Where does it cross at? Negative 2. Fill in your notes, please. Pencil's moving. And we're going to go from this point to this point. So this time we're rising up. 1, 2, 3, run 1. So positive 3 over 1. So now I have my equation, y equals 3x minus 2. All right, what type of lines were these? Intersecting. Any questions on the reverse method? All right, let's write the equations. Equation 1, I'm going to start with the blue line. We're locating m. We're locating b. M, start with b, sorry, is positive 5. And we're going to go down 1 and right 1, 2, 3, 4. So down 1 would be negative 1, right 4 is 4. So the slope is negative 1/4. I have enough info to write my equation. Y equals negative 1/4 x plus 5. Always have your y and x in your equation. Green line, find your m and b first. B starts right here. What point is this? 0. B equals 0. So we're going to go down 1 and right 4. So this has the same slope. We know that because what type of lines are these? So y equals negative 1/4 x. Do I need to put plus 0? No, just y equals negative 1/4 x. Type of lines, we said, parallel. They have the same slopes but different y-intercepts. This one started at positive 5. This one started at 0. They cross the y-axis at different points, but they have the exact same slope. All right, number 3 on these. Parallel lines, again, we can tell they don't intersect. So let's start up here with down here, equation 1. All right, it intersects at positive 1, so B is positive 1. My slope is down 2. Down 3, so negative 3, right 2. So negative 3 over 2. Let me do the blue one now. The equation line 2. It intersects up here at positive 7. So B equals 7. And this one goes down 1, 2, 3, right 2. So negative 3, positive 2. All right, so same slopes, different starting points. So let's write those equations. So this one would be y equals negative 3/2 x plus 7. And this one would be y equals negative 3/2 x plus 1. They had different starting points. Type of lines, parallel. This time it says, I totally butchered that. Let me try this again. Parallel. And what type of solutions does it have? Oh, no solutions. I almost messed up there. I'm trying to go too fast. No solutions. Parallel lines. Last one. What type of lines are these? What do we call this? Intersecting. So let's start with the first line up here. The y-intercept looks like 6. B equals 6. I want to find my slope. Looks like it's down 1, right 1, down 1, right 1. So that'd be negative 1 over 1. The equation would be y equals negative x plus 6. Negative x plus 6. Did you remember? Negative 1 means just negative x. Okay. Equation 2, this line, it crosses the y-axis right here at 0. So B equals 0. All I'm going to find my slope. It looks like it goes rise 2, run 1. Rise 2, run 1. So that's positive 2 over 1. So my equation is y equals 2x. Type of lines, intersecting. And the solution is right here. That is at 2, 4. It intersects at 2, 4. Great job. Last part is to tell, is this a solution for both of them? How can we tell? Plug the point into both of them, solve, and see if it works for each of them. So let's try one of these. It's super easy. You just take the x and y. Remember, the first number is the x. The second number is the y. The x goes out here next to the slope. The y comes in front before the equation. All right, so you got to remember your places for that. All right. I need to go back. Sorry, there's some blanks. One more. Sorry. Plug it in the point to both equations. You solve. And if both equations create a true statement, then it will work for both of them. You got your notes filled in? Sorry about that. I went too fast. All right. I think you got this. You remember x is first, y is second. X goes here, y goes here. Let's try this. So we want to see if negative 4, 3 is going to be a solution. So this is where you would want your calculator. So this is your x value, and this is your y. I like to label them so I don't forget. So we're going to plug in the x here and the y here. So this will be 3 equals 2 times, 2 times negative 4, and we want to add 11. Calculator does this for us. So take your calculator and do 2 times negative 4, add 11, and see if you get 3. And you can also work it out if you don't have your calculator. What's 2 times negative 4? Negative 8. What's negative 8 plus 11? 3. Does 3 equal 3? Yes, true. All right, now I want to try it. It works for the first one. So now we need to see if it works for the second one. So we're going to do the same thing again. Take the 3, plug it in where the y is. So 3 equals, and then we're going to have 5 times the x value up here, which is negative 4. And this time we're adding 19. Take your calculator, if you have it, and plug this in. Work the right side. Whew, my pen keeps messing up. All right, what's 5 times negative 4? Negative 20. Add 19. What's negative 20 plus 19? Negative 1. Does that equal 3? False. No. So this is not, the answer here would be no. It is not a solution to the system. It's a solution to the first equation, but it's not a solution to the second equation. So this point is a point on this line, but it's not a point on this line. Let's do maybe 1 or 2 more. Here's my x. Here's my y. Remember, plug the x in where the x is, the y in where the y is. So the first equation, I'm going to separate my paper here, will be negative 3 equals negative 2 times positive 3, because x value is the positive 3, plus 3. And I'm going to solve this. Starting with negative 2 times 3, which is negative 6. Negative 3 plus 6, negative 6 plus 3 is negative 3. Does negative 3 equal negative 3? That one is a true. All right, let's try the right-hand side. So we're going to do this equation over here. I did this equation here, and I'm going to do the bottom one over here. So organizing your paper while you're doing this is important. The x value was 3 minus 6. This one's easy. What's 3 minus 6? Negative 3 equal negative 3. True. So this one is yes, it is a solution to the system. This point, 3, negative 3, is on this line for this equation and this line for this equation. It solves both of them. All right, you can go ahead and finish the other examples on here. I'm trying to see if there's maybe a tricky one. Let me do this one with you, this bottom one, because there is a negative sign there, so I want to talk about that. So the top one I'm going to do here. So I'm going to have negative 1 equals 4 times 1 minus 5. 4 times 1 is 4. 4 minus 5 is negative 1. Negative 1 equals negative 1. This one's true. Okay, I'm going to do this one over here, though. So this will be negative 1 equals negative sign. And then you put your 1, okay, because that's your x value, minus 4. So it's like multiplying a negative times 1. What are we going to get here? A negative 1. Bring down the minus 4. What's negative 1 minus 4? Negative 5. Does that equal negative 1? No, false. So the answer here is no, this is not a solution to the system. It works for the first one. It doesn't for the second one. Are there any questions? All right, so now you have 2 assignments. You have 4-1 practice, which is attached. You guys are going to get that in just a second. There is a little bit of each of this, graphing, then telling the equation, writing the equation, and then telling if it's a solution to the system. I just need to see the graphs, the lines, and then finding M and B, and then plugging it in. You can use your calculator on that part, but at least write it down plugged in. All right, and then you do have a Delta Math assignment. There's not many problems. It's graphing lines, okay? If you are joining us from home, your assignment should be next in the learning pathway.